Okay, on section 13.3, we're doing rational exponents, and all that means is that they're going to be fractional exponents. So our exponents are going to be fractions. And I'm going to give you this just generic form. If I have a to the m over n, we can rewrite that, and the base is going to go underneath the radical. The denominator, and then is the index, and then our exponent comes over here. Sometimes this m could go underneath the radical next to the a, but I'm going to work through them this way. So if I have 9 to the 1/2, we're going to rewrite this using this form above. So the base goes underneath the radical. The denominator comes the index, and then the 1 is over here. So I'm just going to simplify that. So the square root of 9 is 3. And 3 to the first power is 3. I have negative 64 to the 3/2. We are not going to put the negative underneath the radical. We're just going to carry it along with us, and our answer will be negative. So I'm going to just kind of keep it on the outside. The base goes underneath the radical. The denominator is the index, and then the numerator comes over here. Again, I'm just carrying that negative with me. The square root of 64 is 8. And then 8 to the 3rd is 512, and I'm going to keep that negative with me. If it were written as negative 64 in parentheses to the 1/3, we are going to put the negative under the radical in this instance. So I've got negative 64, and it's just because it's in parentheses. The index is 3, and then 1. So the cube root of negative 64 is negative 4. And negative 4 to the first power is negative 4. Okay, so this one has the negative out front. We're not going to include it under the radical. We're just going to carry it through, and our answer will be negative. And we have a fraction. So underneath the radical, I have 4 over 25. The index is 2, and our exponent's 1. So the fraction, we just simplify each of those separately. So the square root of 4 is 2. The square root of 25 is 5. And bring the negative down with us. So that's just going to be a negative 2/5. Now, when the negative is in the exponent, I'm going to kind of ignore it in the beginning. Anytime this negative is here, our answer is going to be the reciprocal. So just kind of remember, we have that negative exponent, that our answer is going to be the reciprocal. So I'm still going to work through this. Let me rewrite this, 100. So I have 100 under the radical. My 2 is the index. The square root of 100 is 10, and 10 to the first power is 10. Now, because of this negative in the beginning, we have to do the reciprocal of this. And this right now is 10 over 1, and the reciprocal would be 1 over 10. So anytime you have a negative for an exponent, you can just ignore it, work through it, and then at the end, make your answer the reciprocal. Let's do another one. So 8 to the negative 2/3. I'm going to recognize this, and so remember that my answer is going to be the reciprocal. So I've got 8, 3, and 2. So the cube root of 8 is 2. 2 squared is 4. And then the reciprocal of that is going to be 1/4. So when you have a negative exponent, make sure you do the reciprocal. I think Hawk shows you a different way to do it. This is just the way that I prefer to do it. So 8 over 125 to the negative 1/3. We'll have, under the radical, we have 8 over 125. This is the cube root. Oops, I'm just going to, forgot. It's going to be the reciprocal, so I'm actually going to ignore this negative. The cube root of 8 is 2. The cube root of 125 is 5. And so 2/5 to the first power is just 2/5. But remember, I have that negative exponent, so I have to do the reciprocal. So I'm going to flip that, and that will be 5/2. Okay, so there are a couple of other exponent rules that I want to remind you about. So if we have a to the third times a to the second, if you remember when you are multiplying, what you do with the exponents, you're going to add. So this is a to the 5th. And when we're dividing exponents, so a to the 7th over a to the 4th, in this instance we're going to subtract. It's a to the 3rd. These exponent rules are on the formula sheet, but they're also something you should be familiar with. I'm just kind of reminding you. So if I have a to the 3rd, and I'm going to raise it to the 5th power, then I'm going to have a to the 15th. So these are just a reminder of the rules. On this section, those exponents are going to be fractions. So you're still following the same rules. When you multiply, you add the exponents. When you divide, you subtract. And what you'll need to remember also is when you're adding and subtracting fractions, you have to have a common denominator. So for instance, if I had a to the 3/4 plus, times a to the 2/3. So we're going to add the fractions. And in order to do that, we have to get a common denominator. So our common denominator between 4 and 3 is going to be 12. 4 times 3 is 12. 3 times 3 is 9. 3 times 4 is 12. And 2 times 4 is 8. So what I'm actually adding here is 8 to the 9/12 plus 8/12. And 9 plus 8 is 17. So we'll have a to the 17/12. If I have a to the 2/3 divided by a to the 1/9. So I have a to the 2/3 minus 1/9. Again, we have to get a common denominator. My common denominator is going to be 9. So for this first one, I'm going to switch this to ninths. 3 times 3 is 9. 2 times 3 is 6. So I'm going to have 6/9. And the other one's already 1/9. So I have a to the 6/9 minus 1/9. It's going to be a to the 5/9. So you're still following the same rules. You're subtracting the exponents when you're dividing. You just have fractions. So this one, we have a number and a variable in the base, so I think I'm going to write those separately. So I've got 2 to the 4th and a times 4/7 to the 4th. So 2 to the 4th is 16. And then when I multiply here, this is like 4/1. Well, it is 4/1. So 4 times 4 is 16, and 7 times 1 is 7. So that will be our answer for that one. Okay, so this one, this takes us back to what we were doing in the first part of this video. So in the beginning, we had fractions and we put them in radicals. We can do the same thing. We can take this radical and put it into a fraction. So if you remember, the term under the base, the term under the radical is the base. So I've got x. The index is the denominator, and this exponent here is the numerator. So this becomes x to the 5/2. In the denominator, I've got my base is x. The 4 is the numerator, and the index, which is 2. And the 2 isn't written here, but it's assumed to be a 2 because it's a square root. So anytime that it's a square root, your index is a 2. Like this is a 2 out here. So then now we can follow the exponent rules. So 5/2 minus 4/2. We already have a common denominator. So we have x to the 1/2. I'm going to do one more. Just kind of combines a couple of them. So what we can do is we have 3 exponents, so we can get a common denominator for all 3 of them. So I made this 4/1, and our common denominator between 4, 8, and 1 is going to be 8. So I'm going to switch each of these to be 8. 1 times 8 is 8. 4 times 8 is 32. 4 times 2 is 8. 3 times 2 is 6. And this one was already 8. So now I have a to the 6/8 plus 5/8 over a to the 32/8. And we're adding in the numerator. 6 plus 5 gives us 11. And now we're subtracting. So 11 minus 32, that's going to give us a negative, but it would also make sense to go ahead and put the larger number on top. But what we're going to remember is that the bigger fraction is the bigger number for the numerator is in the denominator of the fraction, so our answer is going to go in the denominator. So if I do this 32 minus 11, so I'm going to have a to the 21 over 8, but it's going to go in the denominator. So I'm going to write this as 1 over a to the 21 over 8.